Hi everyone. This video is going to be me going over circles and ellipses. This will be all the information you need for quiz 6 that's due on Friday. So I'm just going to be going through the notes that I've got here, but you can always take a look at these, but I just wanted to give some context for them. Okay, so starting off, I've got the circle equation. So we've got x squared plus y squared is equal to r squared, where r is the radius. And so something like x squared plus y squared is equal to 10. That would have a radius of square root of 10. So just remember to take that square root of the value that's on the right-hand side. This one is centered at the origin, but this second one down here has a center of x is -1 and y is equal to 2. And this is just something that you may have to think that's opposite what your intuition is, because your intuition might be to let x be +1 and y be -2, but it's actually you have to change the signs for this. X has to move an additional 1 space in order to reach that spot. So the real center of this one is -1, 2, and the radius is 2. Looking at this one, you may originally think that the radius is equal to 1, but again, this circle equation, it's got to be in the form x squared plus y squared equals r squared. So in this third equation, I've got these terms, but since I want this to look like x squared plus y squared, I do need to multiply both sides by 100. So when I do that, multiplying both sides by 100, I get x squared plus y squared equals 100. And from that, I can tell the radius is 10. So that's circles. Ellipses are just stretched out versions of that. So I'll start off with the ellipse equation. The ellipse equation is x squared over a squared plus y squared over b squared is equal to 1. And the important thing about this form that's different is that on the right-hand side, we've always got this equal to 1, okay? So our goal is always going to be figuring out what we can do to get it in this form where the right-hand side is equal to 1, and we've got x squared and y squared terms. So looking at this first one here, I've actually got two versions where the numbers are switched around, but looking at just this one on the left, I've got x squared over 4 plus y squared over 36 is equal to 1. And I want to know what are a and b in this equation. So take a second to think about what you would write down for a and b. And it turns out in this one that since a squared, this number here is 4, a is 2, and b is 6. And just the opposite over here. But let's just focus on the left-hand example here. The ellipse that we draw is going to look like this. So notice how in the equation b is underneath y and a is underneath x. So those correspond with each other, right? X corresponds with a, so this horizontal distance from the center out to the sides is always going to be a, and this center up to the top is always going to be b. So in this other case where a and b are switched, again, a is still on that horizontal axis and b is on that vertical axis. If you see some reference to major and minor axis on here, that just means the larger of the two axes is called the major and the smaller is called the minor. So on this one on the left, y, and by extension, b is the major axis, a is the minor. Over here, b is the minor axis, a is the major axis. Okay, so you may be asked to give an equation for a ellipse that looks like this. So you would just sort of measure from the center to the side of the ellipse on the top and the right-hand side, and that'll give you your A and B, which you can square and set up in here. But you may also have to work with this equation and figure out what A and B are, or figure out what the shape of that looks like. Okay. Another form you might see would be something like 4x squared plus 25y squared is equal to 900. So this is also an ellipse, but this ellipse is not in the right form. Yeah, so it may be a little bit more difficult to figure out. I'm trying to think about, is this a horizontal ellipse like this or a vertical ellipse like this? But in order to get this in the right form, remember we want x squared over a squared plus y squared over b squared is equal to 1. So we always want it to be equal to 1 on that right-hand side. And so my first step is to divide everything by 900 because I want that 1 on the right-hand side. So what I'll end up with is x squared over 225, y squared over 36, and that's equal to 1. Just a quick note here. If you put 4 over 900 into your calculator, you may get something that's not helpful, right? You might get a number that looks like 0.004, and you want to, in that case, either convert it to a fraction, so that should be a button on your calculator. If you're using GeoGebra, if you type in 4 divided by 900 and get the answer, it will give you a decimal answer. But what you want to do is go ahead and just click the arrow. So there's a little blue arrow that appears next to it, or a blue approximation symbol, and that'll convert in between decimal and fraction answers. Another technique would be, so I could get this 225 by, instead of doing 4 divided by 900, I might do 900 divided by 4. That way I can just get this number readily. But in any event, if I divide everything by 900, I get this equation, and it's equal to 1, which is what I wanted. Okay, so from here, I can just figure out what A and B are, and I can use those. So remember, A is associated with X. So since A is 15, these points on the ellipse are going to be at 15 and negative 15, and B is 6. So this will be the point 0, negative 6, and 0, 6. Okay. So yeah, mostly just a matter of getting this in the form of an ellipse equation where it's got 1 on the right-hand side, and then solving for A and B. That should give you all the information you need to figure out what that ellipse looks like. Another way to think about ellipses is in terms of focus points. Sometimes these are called foci, F-O-C-I. But focus points are going to be 2 points that have this relationship on here. So if I pick any point on this ellipse, and I'll just contrast this with a circle really quick. So for a circle, any point on that circle, let me get a better pen here. So for a circle, again, any point on that circle is equidistant to that center point there. All right, so that distance is, of course, the radius. But for an ellipse, we have different radius values. So instead of everything being equidistant from one point, we could say that if you look at these 2 focus points, any point on the ellipse, so point P, for example, if you add the distance that it takes to measure to these 2 focus points here, that will be the same distance as these 2 red measurements here. So I've got the equation written out here. But this is true for any point on the ellipse. If you add up these two distances to focus point A and focus point B, that'll always be the same distance everywhere on the ellipse. So in terms of figuring out where these focus points are, we do have equations for that. So that's what I'll show you next. I've got my same two equations, or my same two ellipses that I looked at earlier. So these two ellipses are going to be where A is 2 and B is 6, and A is 6 and B is 2. So on this one here, it's a vertical ellipse, right? Like A is less than B. B is the larger of the two. And so that means that my focus points, they're going to fall on this y-axis here. And I've went ahead and figured out where those focus points are. I'll show you the equation in just a second, but I'm going to call this coordinate 0, C, and this one's 0, negative C. So just to kind of say it's the same number, right? This distance and this distance are the same. So that distance is sort of similar. I'll call this one C as well, but those are on the x-axis this time because I have a horizontal ellipse. But the equation for these depends on whether you're looking for a vertical ellipse or a horizontal ellipse focus points. In the case where B is greater than A, like it is here, so looking at a vertical ellipse, C squared is going to be equal to B squared minus A squared, where those A and B are just the same things from the formula here, so 36 minus 4. But it's always going to be the larger or major axis squared minus the minor axis squared. So if I solve for C, I get square root of 32, which is around 5.65. And over on the right-hand side, this is the case where A is greater than B, so a horizontal ellipse. And if I solve for it, here A is 2 and B is 6, and then over here A is 6 and B is 2. So I actually end up getting the same number, but the way that I apply it is now those are the x coordinates. So negative 5.65 and 5.65 are my x coordinates, and here they're my y coordinates over on the left. One little last piece of, so this is the more generalized version. So if you have you want to make sure your ellipse is in the right form, where you've got 1 on the right-hand side. But this sort of formalizes everything that I did in those above examples. The last thing I want to talk about with the focus points is just more of a sort of a trivia fact about focus points that's just a point of interest. But for the exam, I just want you to focus on moving in between the equations of circles and a drawing of circles, equations for ellipses and the drawings of ellipses, and finding the focus points. So sort of those first 3 topics are really what I want you to be focusing on. But this second piece here, this says that, and I'll go ahead and, well, looks like that eraser's not going to do what I want it to, but so I've got an ellipse here, and I drew it green because there's a interesting video that I'll link to that talks about a elliptical pool table, right? Billiards. So the idea behind that table is no matter where you hit it, so they would start with the ball here, no matter where on the sides you hit it, it's always going to go into one of these 2 pockets on here. So these 2 pockets are focus points, but the result of that, if we just look at the blue here, I've drawn a tangent line. So I've got some point on the ellipse. I've got a tangent line here. But any point that starts anywhere inside of that ellipse and travels to the travels to this point here, and that will always bounce back into a focus point. So the way that you'll use this in a quiz problem potentially is that this angle, what we would call the angle in, is equal to the angle out. So these names are sort of arbitrary, right? Like we're calling this the starting point, and then it travels here and then back out again. So anyway, this angle that's formed with the tangent line and this angle that's formed with the tangent line will always be the same. And that's true for any point on the ellipse and that tangent line. So I've drawn another one here that's not on the focus point, but these two angles will be the same as well. Okay, so that's all you'll need to know for circles and ellipses, and I'll link that elliptical pool table video in the description.